Hello everyone, welcome back to another AP Physics 1 Dynamics Daily Problem. Today we'll be going over question 6 in the AP Physics 1 MIT workbook. That'll be in the description down below for you guys to follow along. With that being said, let's go on with the question. It says a block of weight W is pulled along a horizontal surface at a constant speed V by force F, which acts at an angle of theta with the horizontal as shown above. The normal force exerted on the block by the surface has magnitude, and then our choices are greater than W, greater than 0 but less than W, equal to W, and then 0. So one thing I'd like to do in these problems is just looking at the answer choices and see what we're always comparing it to. And as we can see that W always comes up in all of these answer choices or 0. So we need to know what W is. So it says a block of weight W, meaning we have a weight force acting on this object. And we know that force F is acted at an angle, meaning we're going to have both an x component and a y component. And if we remember, to get our x and y components, we have to multiply by the sine and cosine components of it. So taking the theta and using our trig identities, we can do the opposite over hypotenuse would give us, this would be sine of theta is equal to opposite. So this is the y component. So Fy is over F, and then our horizontal component would be theta is adjacent over hypotenuse. So then cosine of theta is equal to adjacent. So this would be our force X over force F. And if that didn't make sense, that is probably something dealing with your trigonometry. And I would advise getting a hand of this and like making sure you can get it down, because this does come helpful in the AP exam when time is of the essence. So now that we know we're comparing the weight force, so the weight force is going to be acting downwards, W, weight force, we want the vertical component because that's what we're going to be comparing. Because we can't compare the horizontal component with the vertical component because they're not acting in the same direction, meaning they're not going to affect each other. So knowing that, we have to go ahead and calculate what the force in the y direction is. And we have this equation over here to tell us that. So knowing this, we could just multiply by F, and this cancels out, giving us that the force in the y is equal to F sine theta. Now that we know force y is F sine theta, we can go ahead and make Newton's second law equation, which is F equals ma. And I'm going to say this time and time again, but F equals ma is something that you guys have to remember for these dynamic problems that will always come in handy. So now that we have our force equals mass times acceleration equation, we have to remember one thing. In the problem, it says that a block of weight W is pulled along a horizontal surface at a constant speed V. When it says constant speed, that means the speed is not increasing. And if the speed is not increasing, that means the acceleration is 0. And knowing that the acceleration is 0, we can go ahead and add a 0 to the side, because if the acceleration is 0, 0 times anything is going to be 0. So we can just say F is equal to 0. And knowing this, we can go ahead and solve for the forces in the y direction. So we can say force y is equal to 0. And you may be wondering, what are the forces acting in the y? Well, we know one of them is force y, which is equal to F sine theta. So we can go ahead and say F sine theta. And then we have our weight force, which is also acting in the y direction. So we have weight. And then don't forget, Newton's third law, for every action, there's an equal opposite reaction. So as the weight pushes down, there's also a normal force acting on the other side, meaning that there's also force normal. And this all equals 0. And making our sign charts, me personally, I like to have up being positive and down being negative. We can see that the force normal and the force y are both acting upwards, so this would be a positive, and then the weight force is acting downwards, so we're going to have a minus W. Okay, now that we have our forces in the y direction equation, we can go ahead and put W on the other side to compare it. So if we put plus W, this cancels out, and we get F sine of theta plus force normal is equal to W. And just this equation alone gives us a lot of information. We know that W is equal to force sine theta plus force normal. That means that force W, so the weight force, is greater than both force sine theta and force normal. And force sine theta, don't forget, this is actually force in the y. This is this force acting in the y direction. So we know that the wave force is greater than the normal force and the force y, because both of them added together is equal to the wave force. And since you can't have two numbers equal the greater amount, that means that they are both smaller than the wave force. And if we know that already, that the force normal is smaller than the wave force, we can already go ahead and cross out choice A, where it says it is greater than W. Because the question is asking us the normal force exerted on the block by the surface has a magnitude, and we know it can't be greater than 0 because these two add up to W. Sorry, greater than W because these both add up to W. So now we have to check if it is greater than 0 or less than 0. And one thing I can tell you for sure is that we know that it is not equal to W, because this force in the y right here, this adds some force from the normal force. And doing that so means that the force in the y has to be greater than 0. Sorry, greater than 0, yes. So since this is greater than 0, we know that this component cannot all come from the force normal. And knowing that the whole component cannot come from force normal, we can cross out it equal to W. And since we know that it can't come from force normal, and we know that force y, the force in the y, F sine, cannot give all of this weight force, we know that there has to be another amount of force coming from the object in the y direction. And knowing that, that would be the force normal, which adds up and makes up for this lack of the y. Since this force has to split its force in the y direction and the x direction, the force normal is going to make up for it, meaning that the force normal cannot be 0. And that leaves us with choice B being our correct answer. I hope you guys enjoyed this video. If you have any questions or if anything didn't make sense, please comment down below and I'd love to respond to that. I hope you guys have a good day and continue your prepping. And remember to enjoy life.